All right. Great. Hi, everyone. By the way, good evening to all of you. Thanks a lot for joining for today's session and also a webinar on practical foundation to computer vision. Great pleasure to see your interest and enthusiasm to learn about computer vision. That's been the hot topic today for the implementation of various requirements. Maybe take it as quality control in manufacturing, up to take it as autonomous vehicles, robotics, or anything as such. Maybe it could be today even in terms of healthcare requirements. Maybe it would be tumor identification, cancer identification, and whatnot, right? So the computer vision has been the major tool for anyone to to be the need of our anyone to be the good with to explore career in the areas of computer vision. So we've been having worked on these systems for quite some time, and Bharat is a person. So we've been delivering and actively involved in creating programs and courses around computer vision. So we have Bharat here today to give you a run through of some of the fundamentals of computer vision and also to a practical foundation with hardware components as well. There is some issue to showcase a backside camera, to see the hardware. I believe Bharat is going to manage along with that. To give you a little bit of introduction about Bharat, so he's been a senior engineer at Decibels Lab in the areas of autonomous vehicles and also ADAS algorithm development. So Bharat has been extensively working on various projects for ADAS and autonomous vehicles in developing algorithms for computer vision, algorithms for motion control, path planning, and various other activities. He's been the instrumental person behind creating a lot of courses also on the Decibels platform, which has helped many engineers to learn and gain activities of the activities on the computer vision projects and stuff like that. So by this introduction, I will hand over the session to you, Bharat, to give the best to have the interest of the participants. Thank you, and over to you.
Yeah, thank you, Suresh, for the introduction. Yeah, good evening, all. So I hope I'm visible. Sorry, I'm audible. So you can just type in yes if the screen is visible and if I'm audible.
Yes, you're audible.
Okay.
Screen is visible.
Oh, cool. So let's go ahead with the session. So the session is divided into 3 sections. So one is with respect to computer vision. The first half will be starting off with computer vision. That will go around like 15 minutes. And then we'll introduce you to Jetson Board. And also the next thing is with respect to the cameras. So like few types of cameras and images of few cameras. And at the last, I'll show you a live demonstration of the hardware. So wherein we could see the actual images that is being captured by the stereo camera by using the Jetson Board. Okay. So first of all, with respect to vehicle, you can think of it as an autonomous vehicle. So there are a number of companies which develop vehicle. So for this, the main thing is like we would require hardware to capture the environment, and based upon capturing the environment, we understand the environment and the vehicle drives by itself. So for this, so if you take an example of a self-driving car, that is Tesla self-driving car. So it has like 3 cameras. So as you can see over here. Okay, so this is like left, center, and right camera. So for all these 3 cameras, so the main first objective by using a hardware would be to capture images. And by using the images captured, we give it to our microcontroller. Okay, I'll write it down over here. So the camera would give the captured images would be given to our microcontroller. So the device which has the computing power and all. So then after the computation, so we'll be getting an output maybe to take a left turn or a right turn or to move forward, or what kind of a decision needs to be made. So the microcontroller will give a decision as an output. So then this decision is given to our vehicle and the vehicle drives. Okay. So in this particular part of it, in the microcontroller, we write certain softwares, or like certain program. So that is wherein our computer vision or machine learning or AI and all comes into picture. Okay. So given the image data, we process it out and get an output. So for this, we would need to understand what are all the few of the types of cameras which are present, or sorry, I mean like the sensors which are present in a vehicle. So in this particular session, we'll be focusing only on the camera. But in terms of an autonomous vehicle, there are a number of sensors, such as like a radar or maybe a camera, and there is also LiDAR. Okay. Yep. Okay. So it's over here, LiDAR. So majorly LiDAR, radar, and camera. So in camera also we have a number of cameras, and in LiDAR also we have a number of LiDARs and different radars and all. Okay. So in terms of this camera, so camera could be present in different locations. So here, if you see, there is one particular location over here. So this is one particular location wherein we place the camera, and then at the front end, at the rear end, we use a number of cameras. Okay. So for this particular part of it, so once we have obtained the images, so next thing is to perform computer vision algorithms and get an output, right? So we'll first understand computer vision. So computer vision is basically like this. Given image, an image could be represented in terms of a number. So for example, if you see here, there is a grayscale image or black and white image. So grayscale or black and white image. So in terms of a grayscale image, so if it is represented 1 or 0, so 1 would represent black, complete black, and 0 would represent complete white. And if it is gray, it's around like 0.5. Okay, I mean like 50% of it. So that's basically how it is represented. So to be more precise in terms of image point of view, it is not exactly 1, but it will be like 255, and this would be 0, and this would be around like 255 divided by 255 divided by 2, which is around like 127 approx. Okay, so that's how we represent a grayscale. So in terms of this particular image, if you observe, there is white. So you can see here, yeah, so I'm sorry, white would be represented 255, my mistake, and black would be represented 0. So I've represented, I've told you in the reverse way previously, but white is 255. So if you see here, this is white, and then based on this, this is a 251. So similarly here, if you see with respect to black, it is 6. Okay, it depends upon the intensity of the black color and the intensity of the white color, the value with respect to each and every location. So now with respect to this each and individual location, you can see the values, right? So this is a matrix. So based on this, if you see, it's around like, yeah, so it's around like 12 values over here, and this is approximately, I'm just writing it out, let's say around like 25. The 12 cross 25 number of values are present. So this is a matrix. Okay, so by using this data, so by using this matrix data, we perform computer vision we perform some mathematical calculations, and then based on that, we'll be able to estimate certain value. So now we have this matrix, right? So the same thing, if you see with respect to this with respect to a grayscale image, okay, black and white. So either black or white or gray. So this is the matrix. But if you look at a colored image, so we have like 3 values. So one is either red or maybe green or maybe blue. So first I'll explain you what is RGB color space, and then we'll look at a colored image, how it would be present, how it would be represented. So if you see with respect to this, there is green, blue, and red. So if you want to obtain any other color, so let's say white, so it's a combination of green, blue, and red. And if it is, let's say, for example, yellow, it's a combination of green and red. So like this, based upon the combination of green, red, and blue, we obtain different colors. Okay. So if you observe here, so with respect to previously, I was saying like for red, so black and white, we would represent a number of pixels. So like number of values for each matrix, right? So wherein 0 would be represented for black, and 255 would be represented for white. So in the same way, here we would have red, green, and blue. So this is like red, green, and blue are like three individual, let's say, color spaces. Okay. So here we have like only one particular color space, either, I mean, like it will be like either white or black. But here we would have three individual color spaces. So this is in terms of red, it would be like if it is completely red, we would represent 255. If there is no red, it would be 0. Same applies to 255 for green and 0 for, I mean, like no green. So now in terms of these red, green, yeah, so green and blue individual values, we get different value, like colors which we obtain. So if you see here, so this is RGB. For red, 255 would be represented. So this is red, green, and blue. Okay. So I'll remove it now. So 255 is red. Okay. Green and blue is represented 0. So because of that, this is completely red. So in the same way, to say with respect to orange, it would be 255, 165, 0. So if you look at maybe another color, that's in terms of black. So RGB, everything would be 0, 0, 0. So based on that, we get black color. So in the terms of white, it would be 255, 255, 255, which means that we're using all colors, which is red, green, and blue. Okay. So that's how we represented, which I mean, like we could represent white color. So same thing applies to other colors and all. So based upon the combination, we get like different colors. So now if you look at an image, so this is what an image contains. So I'll write it down. Yeah, so with respect to a black and white, if you look at maybe a matrix, so let's say this is 255, this is 0, 251, or maybe 127, like this is the matrix, right? Okay. But in terms of a color space, at a single point, okay, if you consider this particular point, and it's a 3 by 3 matrix, I just considered. So in this entire image would be a matrix, okay? So let's say, for example, this image is like 500 cross 500, sorry, 600. Okay, there's the image size. So in this, I'll just consider one particular point, this particular region. So which has like 3 by 3 matrix. Okay. So with respect to that, what happens is like we'll have like 3 individual matrices like this. So one representing the red color, one representing the green color, and one representing the blue color. Okay. So now if you observe, based on these 3 combinations, we obtain this final output. So that you could see in this particular region. Okay. So that's how a colored image is present. So you can see here the individual matrices. Okay. And this is like the output. So similarly, if you look at maybe this particular region, right? So what would happen is like the output that you get, which are, I mean, like the matrix that you get would have like lesser amount of blue value, lesser amount of green value, higher amount of red, I mean, like value would be present because it's a darker red color region, right? So that's how like the colored images would be present. So this is in terms of computer vision. So by using these image data and all, we process it out and we understand the image and get a final output that we require. Okay. So until now, if you have any doubts with respect to computer vision or anything else, you can just type it out in the chat box. So if you don't have any doubts, you can just type in clear and then we can go ahead with respect to the hardware point of view. Okay. So next we'll be looking at like Jetson board and like how like the different types of cameras and all. Okay. So if you look at a Jetson board or any kind of microcontroller, so it's like this. So if you are familiar with the computer, let's say the hardware and all, right? So we would have basically, yeah. So in simple terms, we would have a CPU. So, I mean, like if you look at your CPU, we would have in a CPU, we would have a RAM, and then we would have storage. Yeah, storage, and then we would have other stuff like such as the processor, and then we have a graphic card. Okay, so yeah, so we have a graphic card, and yeah, so these are like basic, like the basic things that we would look at, right? So then after this, like when you want to connect your your mouse, or maybe if you want to connect your pen, yeah, I'll write it down. If you want to connect your pen drive, or maybe your mouse, or maybe let's say your printer, or any other device, you want to connect it on. So for this, we would use other ports or interfaces which would be present. Okay, so that's like USB port. You would have USB port, right? So then Ethernet port, and all. So same thing is, I mean, like similarly is what a microcontroller is. But in terms of a microcontroller, the size is smaller, and the computing power is smaller, and the number of devices which you could connect and all would be lesser. Okay, so compared to a CPU and all. So if you see with respect to NVIDIA Jetson Nano, so it's one of the series board which is present in Jetson. Okay, I mean, like in NVIDIA, there's a series which is Jetson. So in that there is like Nano, there is TX2 and various other boards and all. So this is one of the board which is present. So with respect to this, so as I was saying, like in terms of a CPU and all, we have the CPU, we would have a GPU, which is like our graphic card, okay, which is present, and then a memory. And then as I was saying, yeah, so yeah, I mean, like with respect to computer vision engine and multimedia and all. So then our power, I mean, like we would apply in our power and all. Okay. So yeah, so these are the basic things, and your IPO, like input and output. Okay. So this is what a Jetson board is all about. I mean, with respect to the hardware point of view. So if you see with respect to Intel, I mean, like with your CPUs and all, like we would have like Intel Core i7 or AMD Ryzen processors and all. The same way, if you see here, this is a quad core processor, and I mean, like with respect to that, like the speed and all. Okay. So then with respect to GPU, this is the specification. Okay. And yeah, so similarly with respect to the power and all will be present. Okay. So majorly, if you see here, it's basically everything is like compacted into a smaller size, so which you could use it to your application point of view. So this Jetson board is majorly designed in terms of for AI applications or for machine learning application. You could use it for computer vision application or for controls and various other stuff. Okay. So we'll look at like few of the application point of view so that you get a better understanding. So if you look at an industrial application, is one of the application like in terms of robotics, or if you're looking at aerospace application and all is present. Like you might have heard of drones, or maybe any flights which are present, right? Like automatic flights and all, or maybe in terms of construction, agriculture, healthcare, and many various other stuff. Okay, so I'll just like explain in terms of an application point of view how it is being used. So if you look at a delivery bot, okay, so a delivery bot objective is to move from one particular location, let's say location A to location B, and it needs to drop your, I mean, like deliver your object, I mean, whatever goods is present. Okay, so that's the main objective. So for this, it would use maybe a camera to understand the environment. So the camera data would be given to your controller, and the controller would control your robot's motion. And it's basically your controller acts as your, I mean, like your hardware brain, which is able to compute everything and give us an output. So similarly, in terms of maybe if you look at agriculture, okay, and in terms of an agriculture, you want to, like maybe in terms of farming, when you want to pick up apples, okay. So we have a bot which is able to detect what type of apple, if the apple is good or bad. So we have some kind of a algorithm. Okay. So the robot will be able to select the apple which is good and pick the apple and drop it in your basket. So similarly, if it is bad, it won't select that particular rotten apple, and it won't collect that particular apple. So like this, it could be used in many applications. So depending upon the application, your algorithm would change, and your hardware or the sensors would change, and you would basically get your output. Okay. So that's with respect to an industry point of view, like how we could use it. Then with respect to your camera interfaces and all, I mean, sorry, your Jetson board interfaces and all. So it's like this. So first of all, your power input. So I mean, like your CPU or any hardware device requires a power, right? So we would take in a power as an input. So in terms of power, we get in 5 volts as an input. So we use either a jack or maybe we use a PMIC input. Okay. So based on that, we get a power input. So once that is done, so this would be given to our chipset or the CPU and all which is present, CPU and RAM and all those things, right? CPU and RAM, all this would be booted up, your storage and stuff. Okay, power input, and once it is all your devices have been booted up. So then we start obtaining the image data. So for example, you have connected your Jetson board to a camera. Okay, so this is your camera. So the camera gets, the Jetson board will be able to connect to the camera and take the camera input. So once the input is given to your Jetson board, so here your processing and all comes into picture. So image, okay, I'll write it down from this particular point of view, the data input. So the camera, what it gives us an input is image. So this image is given to a Jetson board. So in the Jetson board, what happens is like your computing occurs. So computer vision algorithm or your machine learning algorithm or AI algorithm works, or any other algorithms whichever is being used like path planning or any other algorithm works. The execution happens here. And then this execution would be given to your, let's say like either maybe your controller to control the vehicle or control your robot and all. So this is how basically it works. Okay. Yeah, that's with respect to the the computing point of view. Okay. Any operational performance difference? Yeah, there is a lot of difference. So if you see with respect to USB and CSI, right? So these are like two different interfaces. Okay. First thing, these are like different interfaces which are present. And based on these, there are like different communication protocols. Basically, if you have a USB port and you use a CSI port. So CSI stands for camera serial interface. USB uses serial bus. So compared to USB, CSI is much more faster in terms of like data transfer or, okay, so the data transfer which is present and all. Okay, and it is much more, I'll say like integrated with respect to the circuit and all. But USB, if you see, the data transfer and all might be lower. So it depends upon your, which USB and all, like which USB versions and all. But basically, CSI is much more, say the transfer rate is much more faster, and it is much, the connection is much more secure. Compared to USB, CSI is much more secure. Okay. I believe that answers your question. Okay. Yeah, so that's with respect to the hardware point of view. Okay, so this with respect to the system which is present, right? So now you need to integrate your system with your other peripherals, like maybe I was saying like camera, right? So camera, this is a CSI port. So similarly, there are like different ports which are present in your Jetson board. Okay, so I'll introduce some of the interfaces. Okay, we say it as interfaces. So if you see here, this is your entire Jetson board. So I'll start off with some of the commonly used ports. So this is your USB port. So yeah, we all use USB port, right? So the same thing is present over here. So USB 3 and all. So similarly, there's other ports and all which we commonly use, such as your Ethernet jack. So if you want to connect it to your internet and all, so this is your Ethernet jack. And similarly, you have the USB micro B. Previously when we used to, like maybe in 2018 or 2015 and all, when we used to buy a phone and all, you would connect it to your charger. So those times we used to use micro USB micro B. Same thing is present over here. Okay. So same way, there are a number of other ports. So in terms of interfacing your camera or maybe other devices and all, we have like different ports. So for power supply, we use the power jack. Okay. And then we use this Percler port, USB micro USB, or maybe we also use other ports and all. So there is, yeah, so we use this, yeah, power select HDR. So we use these kinds of ports and all. So I mean, like, sorry, yeah, so these Percler port, not this one, this Percler port. So for power supply now. So similarly, if you look at maybe to interface with the camera, so interface with the camera or a LiDAR or maybe other sensors and all. So we use other ports and all. So for example, with respect to camera, we use the CSI port. These are the CSI port. And we also use some cameras like uses USB port also. These are the USB ports. Okay. So then coming to part of your storage. So when we want to store any kind of data in your CPUs, we have hard disk, right? So here we use a micro SD card. So here is wherein micro SD card is present for. So I'll show you the hardware at the end, so you'll be able to better understand it all. But for now, just like understand that these are all the ports which are present and why is it used for. Okay. So then similarly, similarly, if you want to connect your LiDAR and all, we use these USB ports. Okay. So then if you see with respect to the Jetson board, we have a heat sink. So what happens is like when you're using the Jetson board, the board might heat up, and because of that, it is not good for the board, right? So your devices, electronics and all gets heated up. So in order to cool the system, we use a heat sink. This is like the heat sink. So I'll show you the heat sink and all. So you'll be able to better understand it now. So then in order to cool your heats, I mean like CPU and all, CPU, GPUs and all. So we use a fan. So to connect your fan, we have another jack. So that is over here, fan header. Okay. So that's some of the commonly used ports which we could see over here. And similarly, if you want to connect any other kind of a devices and all, we have this 40-pin extender, header and all. Okay. So these are like some of the connections. So we'll look at other connections at the end. I mean like at the board and all, so you'll be able to better understand it all. So now coming to part of cameras. So there are basically two types. One is monocular camera, and then there is stereo camera. So not only this, there are like other types such as like night vision camera or infrared cameras and all. Let's not worry about it. But in simple terms, there's like two cameras. So one is monocular camera and one is stereo camera. So if you see with respect to a monocular camera, it's like this. So we have one Percler camera wherein like single camera, such as like you have your phones and all, right? So same way we have like one Percler camera which we use. Not like nowadays, like we have like 3 cameras in our phones and all. But previously we used to get, I mean like if you see with respect to your front camera, there's only one camera. Same way monocular camera means single camera. Okay. First thing is like a single camera. So this single camera could be used in terms of like, I mean like if you look at an application point of view, so you could use it for lane detection, or maybe in terms of vehicle detection, or in terms of like understanding your environment and all. So we use a camera, right? So for mapping the environment, so for computer vision, ML algorithms running. Okay. I mean like to collect the data. Same way if you look at maybe a stereo camera, so it's pretty much similar, but the main difference is like we use like 2 cameras. Okay. So you can see the first camera over here and the second camera over here. So by using these 2 cameras, we'll be able to understand the environment. Okay. So this is like your left eye. I mean, like if you see with respect to your human eyes and all, right? We have like 2 eyes. So left eye and the right eye. Similarly, here we use like 2 cameras. So left camera, right camera and the left camera. Okay. So the main disadvantage, main difference is, so here we'll be able to, in the stereo camera and the monocular camera. So in the stereo camera, we'll be able to estimate the depth, okay, the distance. So for an example, we have attached this Percler stereo camera to your autonomous vehicles. And let's say for an example, there's your vehicle wherein your camera is present, the stereo camera. And in front of your vehicle, there's another vehicle. Okay, there's another vehicle. So we want to estimate the distance between these 2 vehicles. So from this Percler point to this Percler point, what is the distance? So by using monocular camera, it is very, I mean, like it is challenging to estimate. Okay, I mean, like it's not so accurate, but if you look at stereo camera, we'll be able to better estimate the distance. Okay, so by using two different, by using the left and the right camera. So that's the major difference with respect to a stereo camera and the monocular camera. So then coming to part of interface, so you can see here, there's a ribbon cable. So by using this ribbon cable, we'll be able to connect to a CSA port. So with respect to a single monocular camera. Same way, if you see with respect to a stereo camera, so you can see here, this two ports wherein we have these two individual ribbons which are connected to the Jetson board. So this is how we interface it out, and then we get our image. We'll be able to collect our images and all. So we'll look at these individual cameras as an application point of view, so that you get a better understanding. So what we've done is previously I've shown you the connections, right? Same way we have connected the camera, and by using this particular exact camera, which is around like 8 megapixel, the image resolution, we were able to take an image. So this is one example image. So in terms of a lane detection and all, right? So we need to detect the lanes which are present. So this is like your lane as an example. We have just created the environment. So based on this particular image, camera, we have collected an image. So by using this image, we'll be able to detect our lanes. So if you see here, this is the lane that has been detected. So there's the image and there's your lane. Okay. So by using computer vision techniques and all, we have detected the lane. So similarly, if you look at a stereo camera, so so this is your object. With respect to a stereo camera, this is your object. So when we use a single monocular camera, right? So for example, the monocular camera is over here. So this is probably what we see. Okay. But when we use a stereo camera, so it'll be at certain distance with each other. So based on that, this is your left eye or right eye or right camera. So this is your left image and right image. So by using these two individual images, we estimate the distance and all. Okay. So you can see over here the object, and this is what the first image is, and there's the second image. The left image and the right image. So as an application point of view, you could see, as a actual image point of view, this is like the image which has been collected, the left image and the right image. Okay. So I'll try to see if I could show you the actual hardware. So before that, if you have any doubts, you can just type it out in the chat box so that I could clarify that out and then go ahead with respect to the hardware showcase. Okay. So first of all, I'll just open up the programs which I would be running. So I've connected the Jetson board. So I'm just interfacing it with the hardware. So by using Wi-Fi, I'm just connecting it out to the Jetson board. Prem, I'll answer that particular question at the end of the session, so it'll be easier for you to understand. Yeah, just give me a second. It's the Jetson board is still booting up. So now if you see, I've connected it out. So this is the Jupyter notebook. Okay, so via which I'm able to connect it to the Jetson board and get the output. So I've connected the stereo camera. So as I've previously shown over here, the stereo camera, right? So I've connected the stereo camera to the Jetson board. So after connecting it out, I'm running the program. Okay. So now if you see, the first thing is I'm collecting the data and all. You can just look at this particular one. So CSI camera, okay. I'm capturing the left and the right image individually. So the image resolution is 3280 and height is 2464. That's your image resolution. So it's a 4K, let's say camera. So after collecting it out, I'm printing out the shape and all. So there's the image size. So if you say like pixels of the image, right? It's a 4K image. And all. So there's a height and there's a width. Okay. So then coming to part of the image. So this is a live image which is being collected. Okay, so just give it a few seconds. So you can see the image and this is your object. Yep, yeah, probably the lighting conditions is not so good here. So you can see the object over here. So I'll mark it out so you can better look at it. There's your object which I've placed in front of the camera. So there's your left image which has been collected. And then coming to part of right image, let's look at it. Yeah, so probably I'll remove this so that you can see the difference. Okay, so you can see the left image and the right image. So the two images which is present. So by using these two images, we'll be able to estimate the depth. I mean, like the distance and all, right? So I'll just showcase you the output. Okay, so so we've got the two images. So next thing is like by using these two images, so the distance is being measured. So just give a few seconds. Yeah, so based on that, okay. So yeah, I mean like the lighting condition not so good. So because of which it's not able to detect it out. But if you see here, with respect to the output, you can see that this is the object, okay, and you can see like I mean like the distance. So basically, if it is blue, right, it is too far, okay. I mean like the distance is not being measured. It's very far. But we see here, there's more number of disparity, or there are more number of pixels is present. So here the distance would be much more nearer, okay. So that's, I mean like that's what you could observe here. I'll show you like a real I mean like example, so you will be able to better understand it out. So maybe a better image which is present. So you can see these two images. So with respect to these two images, so this is like the previous images which I've shown you. And you could see here the output. Okay. So there's your this thing, and there's your output. So actually, as an actual simulation, I mean like actual images, simulated images, you can see here as, I mean like an actual application where you could use it. Okay. So I was saying like left and right image, right? So by using that, we could measure the distance. So if you see here, there's your car, and I want to measure the distance from the current, I mean like my vehicle to this particular vehicle, what's the distance? So based on that, if you see, this is your depth which has been created. And then this is your, I mean like this is your actual, I mean like the distance, okay? And there's your vehicle which is present in the image. So based on that, you could see here, this is the vehicle in the image. And this is like your distance which is with respect to the image. Okay. I mean like with respect to our vehicle, to that particular bike, what is the distance in terms of meters? So it's around like 30 meters. So this could be used in terms of like, for an example, if you want to overtake the vehicle. So we have something known as adaptive cruise control, you know. So, or maybe if you want to suddenly apply a brake, emergency braking. Okay. So like this, it could be used in many applications. So now I'll just showcase you the hardware. Okay. So that you could better understand the concept. So just give me a second. I'll run the program. Okay, so these are the two images which is being shown to you, the left and the right image. Okay. You could see over here, I mean like based upon the lighting conditions, the image you'll see in different manners. Okay, so just give me a minute. I'll try to see if I could share my screen. I mean like the video. So until that, if you have any doubt, Yeah. Until that, if you have any doubts, type it on the chat box. Because if hello. Hello. Yeah, so I believe it's, yeah, I'm sorry for that, but video is not, I'm not able to share the video. So anyways, I'll show you here the demonstration. Okay. So I mean like the images as an output so that you could better understand the concept. So if you see here in terms of the hardware, so the camera, so whenever, let's say in terms of the camera, when we, let's say, move forward, okay, and we run the algorithm. So based on that, you can see like different images. So for example, let's say, okay, so it's still loading a bit. So that's the reason why. So anyways, like, yeah, okay. So you can see like once I've moved the way board a bit forward, so you can see the output. Yeah, sorry, but I couldn't show you the video. But basically, I mean like the Jetson board, but I'll just show okay. I mean, like you can just check out these images. So if you have any doubts with respect to that, I'll clear it out. So with respect to the Jetson board. But with respect to this particular image, I'll explain the concept, which is the Jetson, I mean like your hardware and all. Okay. So if you see here, there's your CSI port. Or maybe if you see here, there's your CSI port, and there's your barrel jack. I mean, like your power supply, and then there's your micro USB port and Ethernet port, and then your USB ports and all. So there's like your USB ports. Okay, so similarly your HDMI port. So if you want to connect it to your display and all, these the ports which are used, and then your heat sink, and then similarly. If you see here, you can see the other ports. There's your fan port, and there's your fan which I was talking about, fan, which are used. Okay, so yeah, there's your barrel jack. So by using these, we'll be able to connect and get your outputs. Okay, So if you have any doubts, you can just type it on the chat box. If not, we'll go ahead. If you have any doubts with respect to the camera or maybe with respect to how the data is collected, anything, you can just type it on the chat box. Yeah, sorry, I couldn't share the video and showcase you the actual hardware. So due to technical issues, I couldn't do that. But if you have any doubts, I'll try to clear it out. And yeah, yes, I've connected to the Wi-Fi. So by using Wi-Fi module, I'm able to also interface it out and get your output. So that's how you can see over here. I'm using the, like Jupyter notebook via Wi-Fi. Yeah, so in order to link your Jetson board, it's not like you need to only use Wi-Fi. You could use a wired connection also, maybe a USB cable. Yeah, I was showing you a micro USB, right? So you can use that also to connect and interface it out and program. Like if you want to program anything, you can do using the USB also. Okay, so there was another doubt. How would you approach SLAM using monocular vision on Jetson? Any tips? Okay. So first thing is like try to understand how SLAM works. Okay, in terms of monocular vision, right? So we say it as basically visual SLAM first thing. VSLAM is the exact name. So in terms of that, so I'll just like explain you the concept. So by using VSLAM, it stands for visual SLAM. Okay, so visual is wherein your computer camera comes into picture, and we get an image data. Okay, and SLAM is in localization and mapping. Together we say it as SLAM. So over here in terms of, just a second. Yeah, so visual SLAM. First thing is like try to collect the data. Okay, so maybe just let's say you use your hardware and use your camera, everything, and like how I'm showing you the data. Right? So the same way, just like run it for like just maybe run your bot or maybe whichever robot and just collect maybe images and whichever is present. So by using the images, so let's say for 10 minutes, you collect continuously images. So these images, you use it in your visual SLAM algorithm, okay, computer vision based SLAM algorithm to estimate your value, like to create an environmental map, okay. So once you've collected the data, right, so next thing is to use your SLAM algorithm, and then you'll be able to get your output which you want. So that's how you could achieve it out. Okay, guys, so that's with respect to the entire session. So if you have any doubts, you can just type it down in the chat box. Okay, guys, you can also type it on chat box, like how was the session? So if you understood everything. Okay, thank you. Okay, as mentioned previously, so with respect to certificate, yeah, Vinayak, as he has mentioned previously, certificate generated link will be shared in the last segment of the session. So at the end of the session, you'll get, the link to generate your certificate. Okay, so just wait for, that's like 5 minutes, probably in 5 or 10 minutes, you'll get the link. Okay, thank you, Prem. Yeah, so I would suggest you, if you want to work on hardware and all, right? So first, like look at how to integrate the boards and collect your data. So after collecting your data, like any algorithm which you want to run, you could run it. Whichever algorithm that you want to run, you can run it and get your output, final output which you require. Okay, so now I've shown you like one application, that's like lane detection by using a monocular camera. So there are other applications also, maybe like vehicle detection or traffic sign detection and all. So for any kind of application, the first thing is like to collect the data, right? So once you have achieved that, next thing you can build your algorithm and get your output. Yeah. Okay, guys, and also you can fill up the feedback form. So it is just attached in the chat box. Yeah, and if you want to learn more about computer vision and autonomous vehicles, or maybe in terms of robotics, or as I was saying previously, like SLAM and all, right? So we first you need to understand like localization, mapping, and ROS and various other stuff and all. So if you're interested in terms of autonomous vehicles or robotics and all, you can look up our website, which has like a number of courses. So if you're interested in autonomous vehicles and or ADAS and all, and you want to fully understand the concepts and go ahead further in terms of your journey in terms of autonomous vehicles and all, there are these courses and all. Okay, these two courses. Or maybe if you're interested in terms of computer vision only, and you want to learn more about computer vision and all, so you can look at this particular course. Okay. Which is in terms of like computer vision, vehicle detection, visual odometry and all. So if you're looking at like visual SLAM, so there is also visual odometry, which is like similar type of I'll say output, but I mean like if you want to learn more about that, it's present in this particular course. Or maybe if you're interested in robotics and you want to learn more about robotics, ROS and all, so or localization, mapping and stuff. Okay, so you can see this particular course. So whichever course you take up, so the thing is like we start off with the very basics, and then we go ahead with respect to the I'll say the algorithms and all. Okay, so first of all, with respect to this particular course, for an example, so we start with Python. So very fundamentals and all. So then we go ahead with ROS and various other stuff. So you can just like check out this particular website. Okay, lms.decibels lab. And if you maybe let's say want to take up any free courses or free webinars, you can look at this particular section. Okay, so which gives you all the free courses and free webinars which are present and which we'll be hosting in the further upcoming days. Okay, guys, so you can just type it down in the chat box if you have any other doubts. If not, we could wind up the session for today. Okay, guys, you can just refresh once if you're not filled the Google form. Okay, and fill it out. Yeah, just maybe give a minute. Yeah, so you can see the certificate link. It is attached in the chat box. You can use it to generate your certificates.
Thank you, Bharat. Bharat, can you stop sharing the screen so that I can show them how to generate the certificate? Thank you. Just a second. So guys, I have shared a link. In the chat box. So you just have to open the link and click here for enroll for free. Then you'll have to sign up with your Google account, which you have already signed in from our website. Select. You'll land up here. Just scroll down. You can check these things. You can read it and click and continue. You can give us your feedback. I'll just type it test here. And click on continue. Please read the content and then click on continue and bring it in. Now you have to click on this get your certificate button. your certificate will be generated. You can download it as a PDF file, and you can save your certificate as a copy link. You can share it on LinkedIn, Facebook, and Twitter, and tag us so that we can reshare you your certificate. Thank you. Hope you had a good session. Thank you, Bharat, for taking up the session.
Thank you, Vinay.
Yeah, guys, if you have any questions, we have 2 more minutes. Thank you.
Okay, and so if you have any doubts, you can just type it on the chat box. If not, we'll end the session in another 2 minutes. So if you have any doubts on maybe computer vision or robotics or autonomous vehicles, or maybe in terms of hardware, or maybe in terms of like localization, mapping, or maybe robot ROS and all, you can just type it on the chat box.
Bharat?
Yes, Vinayak.
Yes. Someone named Prem has
Yeah,
a
okay, so
question
looks
here.
like there are a few doubts. Yes, Vinayak, you're saying something?
Just a second. Someone named Prem has a question. Depth perception using Monovision. Aura is covered in any of courses.
Okay, so we have not covered depth perception using Monovision. Yeah, but basically what we do is like in terms of stereo vision, we use like 2 images and then we estimate the depth. So in a computer vision based, let's say course, so if you want to learn more about like, let's say, this thing, localization, okay, monocular vision, sorry, computer vision based localization. So you'll be able to understand the techniques which you can use to measure the depth, okay? So by using the 2 images and all, we'll be able to measure the depth and all. So by using that, you'll be able to understand like how to use depth perception. But we have not covered our computer vision course. You can just check out the content, so which will give you a better understanding. How difficult is it for a mechanical engineer to learn all these software things? Okay. Yep. I mean, it depends upon your knowledge that you have, and it depends upon how you're trying to learn it and all. So for example, even I'm a mechanical engineering. So with respect to my journey, what I started right to understand the programming knowledge, and then to understand, let's say if you look at computer vision, to understand how computer vision works. Okay. So then we head on with respect to like the algorithms and all. Okay. So I would say it's like, it's not too difficult to learn things, but it's like basically you need to spend time and understand it out and get your output. Does he have to DSC and okay, like computer vision ROS. So we have like 2 individual courses on computer vision and ROS. Okay, so we have not mixed both of them. Okay, but the thing is like if you are able to understand ROS and if you're able to understand computer vision, so you'll be able to like collaborate each other and get an output. So we have kept it separately, but if you want to learn computer vision and ROS, if you take it up, so then you'll be able to like use both of them to get an output. What is DSA and hard coding? I didn't understand the remaining part of the question. So could you just type it out? What do you mean by DSA? Okay, you're talking about data structures. Okay. Yeah, I mean, like if, yeah, initially, even if you don't have knowledge of data structures a lot, so it's not an issue. But I mean, like with respect to our courses and all, right? We didn't start off with completely showing you data structures and all. So we started with the basics of it and then go ahead with the further part of it. So even if you don't have a great knowledge of data structures, you could still understand and go ahead with respect to RAWs or computer vision and all, and still get your output. So an algorithm point of view is like for all machine learning, or maybe in terms of like Python programming, so or maybe computer vision also, right? So we all use algorithms. So it would definitely be required algorithms to understand. Yeah, thank you, Akash. Okay, guys. So if you don't have any doubts, we'll then wind up the session for today.
Thank you, Bharat, once again for taking up the session. Thank you, guys. Thank you for the people who are watching from YouTube.